Alright, I'll try to make this quick as possible, but probably won't be under 20 minutes. And here we go. First one, factor. Just x, whenever that's the square of that, you just do regular factoring. X squared and x squared. Let's see, minus 25 and negative 4 make 129. I think most of you had this one. X plus 5, x minus 5, x plus 4, x minus 4. All of them equal to 0, so x equals plus or minus 5 and plus or minus 4. Those are 4 answers. That one, subtract the 2 over here, so you got x to the 2/3 minus 2x to the 1/3 minus 35 equals 0. Again, that's the square of that, so we can just factor. And we'll always use that one right there, so it's just x to the 1/3, x to the 1/3. So if I multiply those, I add my exponents, I get that. So multiplies to negative 35, adds to negative 2, that'd be negative 7 plus 5. Set each one equal to 0, so x to the 1/3 minus 7 equals 0. Add 7, so you get 7. And raise it to the 3rd power. 7 to the 3rd is 343. And that one you subtract 5, so you get negative 5 to the 3rd power, which is what? Negative 125. Down here, subtract 8, and so hey, we get the same thing. Just regular old factoring, x to the negative 3rd and x to the negative 3rd. Multiply to negative 8 would be what? And add to posit, so plus 8 minus 1. I didn't even realize that's sum of cubes and that's difference of cubes. That would be interesting. In my free time tonight, I might go home and do it that way just to see what happens. Just because that's how I roll. But for now, we'll just set each one equal to 0. Or wait, I think we're going to have other answers. Because if we just do the thing where we set these equal to 0, I don't think we're going to get all of the answers. So I might as well just go ahead and try it right now. In class, I was just telling you guys to set them equal to 0 because it's easier. So you get that, and then you get 1. That's a negative exponent. So 1 over the x to the 3rd equals negative 8. So 1 multiply both sides by x to the 3rd, and you get that. Divide by negative 8, so you get negative 1/8 equals x to the 3rd. Take the 3rd root of that. So it's just negative 1/2. And then if you do that one, you add 1, so you get 1 over x to the 3rd equals 1. So x equals 1. That's the only logical choice there. But now that I think about it, there could be more. So let's actually, thanks for this, Amy. Let's actually do the sum of cubes there. So let's see, that would be what? X to the negative 1 and 2. And then, let's see, this would be x squared, so x to the negative 2. And then I multiply those, so it would be 2x to the negative 1. And then that squared is 4. And then same, opposite, always positive. And that equals 0. So that one's easy. So we got 1 over x plus 2 equals 0. Right, we can set each factor equal to 0. So 1 over x equals negative 2. So there's your x equals negative 1/2 that we got before. Then there's this garbage right here, which is probably not factorable. Nope, 2 and 2 don't make 2. 4 and 1 don't make 2. And it's not factorable, so quadratic formula doesn't work because it's not a quadratic, it's this weird crap. I'm just thinking out loud here. Sorry to put you guys through this, but let's see. Can I do anything with that? If that is equal to 0. could try to get a common denominator, which I think I will. The common denominator between all of those would be x squared. So that'll stay a 1. That one needs to be multiplied by x, and that one needs to be multiplied by x squared. So I have all that. Multiply both sides now by x squared. And this is going to look like magic to some of you. So now I have 4x squared minus 2x plus 1 equal to 0. Is that factorable? Let's see, 1 and 1, 2 and 2, 2 and 2. Hell, I don't know. 2 and 1 and 2 and 1. 2 and 2 don't make 2. If I make it 4 and 1, I can't get a 2, but I can do quadratic formula now because it is a quadratic. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. That's 16. 4 minus 16 is what? Negative 12. So I got 2 plus or minus the square root of negative 12 over 8. 12 is 4 times 3, so that's 2 root 3i, 2 plus or minus that over 8, so we get 1/4 plus or minus root 3 over 4i. So yeah, I think that should be in there, I think. Thanks, like I said, Yami, for bringing that up. And then that one we could do the same thing, but for the sake of time, let's just not and leave it at that. I'll try not to put one of those on your quiz or test where it gets real crazy like that. Let's see, we got a big thing squared, and then we're going to subtract that over minus 5 times that same big thing, minus 6 equals 0. So then we just factor that like normal. So we're going to have that thing, x plus 8 over x minus 8. Multiply to negative 6, add to 5 is negative 6 and plus 1. Set each one equal to 0, so we'll have x plus 8 over x minus 8. Minus 6 equals 0, so you'll add 6. And then x plus 8 over x minus 8 plus 1 equals 0, subtract 1, get that. Multiply by x minus 8, so x plus 8 equals 6x minus 48. Subtract x, you get 5x, add 48. You get 56, so x equals 56/5 is one answer. And then here, x plus 8 equals, multiply by x minus 8, so that'd be negative x plus 8. Add x, you get 2x, subtract 8, you get 0, so x equals 0. There we go. Going down here. Let's see, same thing, just factor. So it's going to be x plus a, whoops, minus the 21 over here. So what multiplies? So it's this, that, minus 4 times that, minus 21. Multiply to negative 21, add to 4, would be negative 7 plus 3. And then set each one of those equal to 0, so you just get x plus a minus 7 equals 0. Add 7, subtract a, so 7 minus a. And then x plus a plus 3 equals 0. Subtract both of them. There you go. This one's crazy. This one is about like this one, where you're going to get 4 answers. 2 are real, 2 are complex. This one, like I said, with that 6 there, we'd have 6 answers. 2 are real, and then I got 2 of the complex ones, and then you'd have 2 more complex. But anyway, just to do this quickly, let's see, just regular factoring. Let's see what multiplies to 84 and adds to negative 20. 21 times 4, no. This one might take 12 times 7. That doesn't work. I don't know. X squared plus 13 over x. X squared plus 13 over x. What else multiplies to 84? 6 times 14? Is that 60, 24? Yeah. 20. Yeah, there we go. 14 and 6, and both negative, so that it's negative 20. Negative times a negative is positive 84. Set each one equal to 0. So x squared plus 13 over x minus 14 equals 0. You're going to add 14 and multiply by x. So x squared plus 13. I guess I could show the work once. Add 14, add 14, equals 14, then multiply by x. So x squared plus 13 equals 14x. Then subtract 14x, because now we got an x squared and an x in the same equation, so we're going to have to factor. So we got x squared minus 14x plus 13 equals 0. That's factorable. X minus 13 times x minus 1. So x equals 1 and 13. Then we got this one, so we're going to set it equal to 0, add 6, multiply by x. So we got x squared plus 13 equals 6x. So x squared minus 6x plus 13 equals 0. That definitely isn't factorable, so quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c all over 2a. 4 times 13 is 52, 40, 52. 36 minus 52 is negative 16, so we have 6 plus or minus square root of negative 16 over 2. That's 4i. Divide them both by 2, so you get 3 plus or minus 2i. And there's your 4 answers, right? That's 2 different answers. There's the other 2. We'll do more of those Friday, tomorrow, I think. And then this was just review because we need to retake this quiz. So this is just more properties of exponents. I threw a couple on here. Square that bottom, so n times 2 is 2n and y squared, and then on top we got x to the 2n plus 1. This threw some people off, but I showed Riley. I was like, well, if you got 2n plus 1 as your exponent, you could technically break that apart into x to the 2n times x to the 1. Because when you multiply with like bases, what do you do with your exponents? You add them. So if I were to multiply these together, I would get x to the 2n plus 1. So I could rewrite it like that. You don't have to. I'm just showing you why this works. So now I have that and that. So my x to the 2n's cancel out, so I'm left with just x over y squared. Or if you just subtract, 2n plus 1 minus 2n is 1. So x to the 1. It's another way of thinking about it. Let's see, that looks fun. Can I subtract right now? No, I better distribute. So a to the negative 4n minus 8, b to the 3n minus 6 is going to stay the same. That one's going to stay the same for now. And little distributive property there, so negative 3n minus 6. Now I'll just subtract my exponents. So this minus this. Well, negative 4 minus 2n is negative 6n. And negative 8 minus negative 8 is 0. Because negative 8 minus negative 8 is negative 8 plus 8, which is 0. This one, 3n minus negative 3n is 6n. And then negative 6 minus negative 6 is 0. So there we go, just move that down, and that's that. Whenever you use the straight up subtraction method like I did, your answer always goes on top. That's why I put that on top. If you have more questions, obviously tomorrow I'll expect you to ask them. Oh, I was going to do this live, I forgot. So sorry for those subscribers who are just anxiously waiting to tune in. Henry and Simon, I know I let you down, but yeah, I forgot all about that. Anyway, this big old long thing. I don't even know what the answer is. Let's see. Square root of 5 over the square root of 4, so that's just 2. Rationalize your denominator, so that ends up being the square root of 3 over 3. What's 8 to the 2/3 power? let's see, that'd be the third root of 8 squared. 8 squared is 64. The third root of 64 is 4. 4 times 4 is 16. 4 times 16 is 64. Yeah, 4. So that's just 4. So this is 3 times 4, which is 12. Square root of 4 to the third. Hey, didn't we just say that that was 64? 4 to the third is 64. Square root of 64 is 8. 8 times a half is minus 4. I don't remember seeing that on anyone's paper. Hopefully I'm just not remembering, and most of you did have it. Let's see, square root of 27, that's 9 times 3, so that's 3 root 3. 3 times 7, 3 root 3 times 7 over 6, which is 21 root 3 over 6. I remember most people had that. Let's see, moving along to this one. Ooh, that looks lovely. Negative 27 to the 2/3 power. I'm going to go down here, or I'm just going to go up here and do it. Third root of negative 27 times negative 27. Well, negative times a negative is a positive, so then I can forget about those. 27, that's 9 times 3, which is, oh hey, third root of 27 is 3, duh. So I'll bring out a 3 and another 3, so that's just 9, and 9 times the third is just 3. And now the square root of 147, which doesn't even look possible, but 7 plus 4 is 11, plus 1 is 12, so it's divisible by 3. 3 times what's 147? 40? No, 50? Too big. 49. Oh, hey, 7 times 7, so that's 7 root 3. Cool. Now we can combine like terms. I'm going to leave that alone for now. Hey, well, I can't add them yet because I don't have a common denominator, but I'm just going to write them next to each other. And then, hey, there's another one. Might as well just do that just because I'm going to have to get a common denominator. And let's see, 12 minus 4 is 8, plus 3 is 11. Oh, Isaiah, there's the 11 I was thinking of in yours. Maybe you did have it right. Let's see, so common denominator now is 6. So that's times 3. That one is times 2. And that one stays the same. And that one is times 6. And that one is times 6. So now let's add the things we can add. 3 root 5 has no friends. 2 root 3 minus 21 is negative 19. Plus 42 is 23. I hope that was right. Let's go backwards. 42 minus 21 is 21, plus 2 is 20. Yeah, that's easier, 23. Plus 66, all divided by 6. And I think that's all you can do. Yep. That's got to be it. Hopefully. I don't know. I can't think of anything else. Okay, same thing down here. Ooh, I have a minute and 15 seconds to meet my goal. Let's see, square root of x squared is x, square root of y to the third is a y, with a y left over. So what do I have left? I got 3 and a y. Square root of 12, 12 is 4 times 3, so that's 2 root 3. So I got a minus, I'll have a 2 on the outside, a 3 on the inside. X to the third, an x and an x, and a y stays chilling. 27 is 9 times 3, so that's a 3 and a 3. X to the fifth, 5 divided by 2 is x squared there with an x and a y. Hey, they're all having a 3x. Oh, that one didn't have an x left? Nope, that's weird. Alright. Oh, that's why. That's 25 times 3, so that's 5 root 3 with a y underneath. Let's see, that has a square root of 3y, that has a square root of 3y. So I could combine the fronts, but they're not like terms. So the way you write it, I mean, that's like if you had like 2 root 3 plus 4 root 3. Normally you can just add those, so you'd have 6 root 3. But when they're not like terms, xy negative 5, you'd just put xy minus 5. A lot of you would probably write this, and that's wrong. That says xy minus 5 times the square root of 3y, but you need that in parentheses. Or you can think of it as factoring. They have a square root of 3y in common, and if I pull that out, that's what I'm left with, however you want to think about it. So I got those two done. So now these two, same thing. Those aren't like terms, so I'll just put plus parentheses 3x squared minus 2x times the square root of 3xy. And I'm not going to combine them any more than that. So I think we just go ahead and leave her alone. Okay. Tomorrow you can ask questions, and then I'll also have more for you. So let's figure out a time too to take this quiz, to retake this quiz. We'll figure that out. I'll try to make some more practice problems for you. That's all I have to say about that.